So in the last lesson, we looked at things like a profit, cost, revenue, those things. We talked about some independent variable X, the revenue being the dependent variable. Let's talk some more about equations, what they are, how can we solve equations. So I want you to consider these couple of statements, and then we're going to extract from those some things concerning math equations. So how about this? New York City is the capital of Guatemala. Over 1 million distinct species of animals have been cataloged and named. 8 is equal to 5. 13 minus 10 is equal to 3. So the first and third statements are false. New York City is clearly not the capital of Guatemala. 8 is not equal to 5. So that we say that these statements, even though we made a statement, they can be either true or false. 13 minus 10, we did the subtraction, 3 and 3 is equal to 3. This simple exercise illustrated the two key ideas behind understanding equations. An equation is just a simple statement that two quantities are equal. Two sides of these equations, the stuff on the left is equal to the stuff on the right. Okay? Like verbal statements, equations can be either true or false. Like this one, I simply put 8 is equal to 5. I have a statement on the left, a statement on the right, but they're clearly not equal, so this statement is false. We mainly spend time in mathematics working with things where these things are true. Left side is equal to the right side, and it's true. Okay? But like verbal statements, equations can be either true or false. So the statement below contains a variable quantity. Is it always true or always false? And explain. The number of hours you'll spend on homework this week is 14. Well, could be true if you really did the 14 hours of homework, and false if it is more or less time. So here there's the, it could be true or it may not be true. An equation written to represent a statement like this is called a conditional equation, and is the type we most commonly use in areas of math and other fields of study that use algebra. Algebra is just the manipulation of abstract numbers. We don't know what they are, but we can add them, subtract them, multiply, and then later on when we find out what that number is for x, then we can solve it. All of the other things we treat just like the number was already there, but we're just not going to do that last step. Okay. So if we use the letter H to represent the number of hours you spend on homework, we can write that equation as H equal to 14. In this case, it should be pretty clear that the value of H is 14. The equation is true, and otherwise it's false. If H is 14, if it really is, then it's true, but if it's any other one, then it's false. Here, 14 is the only number that makes that equation true. In this statement, you're assuming this thing is true normally and saying H must be equal to 14 for it to be true. A number that makes an equation a true statement when substituted in for the variable is called a solution of an equation. The set of all numbers that make an equation true is called the solution of the equation. Okay? When an equation looks like the H is equal to 14, the solution is pretty obvious. That H is 14. It's kind of a statement of fact. The only way H is going to work here to make this true is that that's 14, the other side's 14. But when an equation looks like something like minus 12y plus 17 is equal to 2y minus 11, it's not so clear if this is true or false. We can assert that it is true and then maybe solve this thing to find out what value of y makes it true. Okay? Our goal in solving equations is to develop a systematic approach to turning an equation, just this statement, whose solution isn't obvious, into one with an obvious solution. But that only helps if we keep this next idea in mind, which in some sense is the most important thing that we're going to talk about in this lesson. The process of solving equations. This is what we're going to do. When we take a statement here and we would like to work toward finding out what value for the variable in there makes it a true statement. Okay? When changing the form of an equation in an attempt to find the solution, anything you do to the equation should not affect what makes the equation true or false. So we want to do arithmetic on this stuff, algebraic arithmetic, to make to find a solution that is going to keep this thing, if it was true to start with, true, and if it was false, it maintains the false. So let's go through a couple of these things. The equation 5 equals 5 is obviously true. 5 is equal to 10 is false. If I multiply both sides of each equation by 2, what can we conclude? If 5 is equal to 5, 2 times 5 is 10, 2 times 5 is 10. 10 is still equal to 10. We still have a true statement. What about this one if it was false? If I multiply times 2 here, times 2 here on both sides, I get 10 on this side, 20 on this side. I started out with false. I end up with a false. So the true equation stayed true and the false one stayed false. Okay. So here's kind of what we learned in this. If I multiply both sides of the equation by the same number, the case was two, the number was 2 in that case, didn't change whether the equation was true or false. If I know that this thing is true, I built this equation so that it was true to start with, I can multiply both sides by 2. Think of it as a scale. If I have 5 pounds on both sides of the scale, they balance. If I double both sides, I've got 10 pounds on each side, they still balance. So that equation, I want you to think about it being a balance, weights on both sides of it. I can add the same weight to both sides, take away weights to both sides, and I still have a nice balance on the weights. So here is something else. We knew that the equation 1 feet is equal to 12 inches. We know that's a true statement. That's an equality. Okay, an equivalent statement. It's the same length. It's just two different measures. So if I multiplied both of these things by 3 feet is 36 inches. Okay, it started out being a true statement. Multiplying both sides by the same number, I still get a true statement. How about this 1 mile is 5,280 feet? That's a true statement. They're the same. And here I've got 1 yard is equal to 1 meter. This is false. But if I multiply both sides of the equation by 0, what happens here? This turns out to be true, and this turns out to be true. So one of the things that I can't do is multiply both sides by 0 and expect to come up with any meaningful next step. Okay, if it was true to start with, it's still true, but if it's false, it becomes true. Okay, so multiplying both sides by 0 is not going to help us any. So here's kind of our rules that we're going to develop as we go along to help us solve equations when we encounter them. We can multiply both sides of an equation by the same number or expression as long as that number or expression isn't equal to 0. So d over 360 is equal to 0.35. I want to know what d is. But look, if I multiply both sides by 360, the 360s will cancel. And that tells me that the d is 0.35 times the 360. And that gives us d is equal to 126. And now let's check it. Let's see if this works. If I state 126, divide by 360, I should get 0.35. This is a true statement. Okay, and that's kind of what we wanted to do. I want this to be a true statement. I want d over 360 to be equal to 0.35 when I write it. And now tell me what that d is. Multiply both sides by 360. The d is equal to 126. So in the solution you found in the colored box, the only solution to the equation, how can you tell? So multiplying both sides by 360 will not change the solutions. Since that only produced one solution, it must be the only one. There's not any other ones that's going to work out. We know that the equation 1 minute is equal to 60 seconds is true. That's that equivalence. So is it true that 1/2 minute is equal to 30 seconds? What did we do here? We basically divided both sides by 2. If I divide this by 2, I get 1/2 a minute. is 30 seconds, which is also true. Okay, so that kind of gives us another tool that we can use. We can divide both sides of an equation by the same number or expression as long as that number or expression isn't equal to 0. So I can't divide by 0. So here, I want to use this to solve 5 times x is equal to 60. Well, if I divide both sides by 5, that 5 is going to cancel. This is 5 times x divided by x is just x. And then 60 divided by 5 is the 12. So here x is equal to 12. So let's check it. If I stick 12 back in here, does 5 times 12 equal to 60? Yes. So that's a good solution. It's true. Started with assumed true, worked with the division, and got it to be true. Here is like a fractional piece of this thing, an equation stating that two ratios, ratio is just a fraction, this side to this, or this amount to this amount. So if you've ever mixed something, it'll say do a certain amount per gallon. So this is this per gallon, but it could be how much is it for a pint, and you could work out it with this. So the equation we solved in question 5 can be written as a proportion if we write the percentage 35% in fraction rather than decimal form. So D, and this is written, D is to 360 as 35 is to 100, or D divided by 360 is equal to 35 over 100. So if I've got something like this, the quick way that you're going to kind of think about this is, how about if I just do a cross multiply? 100 times D is equal to 360 times 35. Okay, so that gives me this piece of it, and then I divide by the 100. So here's going to be the 100 times the D, that gives me that piece, 360 times 35. Okay, and then I'm going to divide both sides by 100 to get to cancel that out, and that'll give me D is equal to 126. So what was all this cross multiplying doing? I multiplied first both sides by 360. Canceled out the 360, then I've got 35 times 360 divided by 100. I multiply both sides by 100. That gives me the 100D is equal to 35 times 360. And then I use what I just known, divide both sides by the 100 to give me the D is equal to 126. So here's another one. The first piece of it, it's not really this times this, I'll consider it this way. 36 times x, 12 times 15. Okay, so that gives me 36x, 12 times 15, and then I want to get rid of that 36, so I do the division here. X is equal to the 180, 12 times 15, divided by 36, and that tells us x is equal to 5. Okay, how about this one real quick? First step, multiply this times this, so 35y is equal to 81 times 10, 810, and then I would divide both sides by the 35. So that we know that 1 minute is equal to 60 seconds. Is it okay to add the number 3 to both sides of the equation, resulting in 4 minutes equal to 63 seconds? We can't do that. 4 minutes does not equal to 63 seconds. When I added 3, the units did not match. 3 would be a pure number. So I can't go 3 plus 1 minute. It has to be 3 minutes plus 1 minute. And then I would be adding minutes over here, so I really need to have the 60, 60, 60 over there. So I have to be very careful when I'm adding, subtracting, multiplying, dividing to make sure my units are working together. Is it okay to add 3 seconds to both sides of the equation? No, again, all I've got is 1 minute, 3 seconds is equal to 63 seconds. And that is the exact same thing that I'm adding. Here's 3 seconds and 3 seconds, not just the pure number 3. Okay. So here's our thing. We can add the same quantity or expression to both sides of an equation. So here, use this use what we've learned so far, use this piece of it, to solve x minus 142 is equal to 70. So I can add the same thing, and what I want to do is do the opposite. So if this is a negative number that I want to get rid of, I want x by itself. That's my game plan. X on one side, all my numbers on the other side. So to get rid of a negative 142, I'll do the opposite. I will add 142 to get rid of this side, but I've got to do the very same thing to the other. So I'm going to add 142 to both sides. That negative and that positive is going to be equal to 0. And then I've got my x by itself, and it tells me what the answer is. X is equal to 70 plus 142 is the 212. And now if I took this 212, stuck it back in there, does it still give me a true statement? 212 minus 142, 70 is equal to 70. That's true. And that lets us know that we hadn't made any mistakes and we've got the correct answer. Here I'm going to kind of do that in a two-step process. I would add plus x to both sides so that it would be just, instead of saying negative x is a number, I want to know what the positive version. So I plus x to both sides. X plus 230 is equal to 63. Then I would subtract off 230 from both sides. So the answer would be x is equal to 63 minus 230. Okay. So given the fact that 36 inches is equal to 3 feet, subtract 5 inches from each side of the equation. Is the resulting equation still true? So 36 inches minus 5 inches, this is 31 inches. And now if I did convert that into 2 feet, 12 inches, that's the third feet. And if I subtract off 5 inches, I get 31 inches is 2 feet 7 inches. So that's true as long as I'm maintaining what units I'm working with and being careful. It's fine. I can deal with that. But just a pure number, subtracting 5 from both sides, I don't know what 5 is. Is it 5 yards, 5 minutes? That I can't. It's got to be the very same units before I can subtract those off. So we can subtract the same quantity or expression from both sides of an equation. Use your answer above to solve this equation. N plus 1361 is equal to 2094. So this, I want the n by itself, leave that alone, and I'm going to do the opposite. So if this was plus, I'm going to do that subtraction, minus 1361, both sides. I have to subtract the same expression from both sides. And that gives me the answer. So here goes to 0, 1361 minus 1361. And on the right side, 2094 minus 1361 gives us the n. That's the only thing left on the side, is equal to 733. And when we solve an equation, that's what we want. The variable on one side, all by itself, is equal to a number on the right side, or switched. But I need to have the variable by itself, the number by itself. Okay. And if I check this, 733 to 733 plus 1361 equal to 2094. Run it through our calculator, and we still have the true statement. So let's summarize kind of what we can do here. Here's the steps that if we're going to solve linear equations. We're going to have one variable. Okay, so this is only in one variable, x's. Simplify both sides of the equations if necessary. So we're going to expand everything out. Multiply out any parentheses and combining any like terms. That's the simplification on both sides. And then we're going to use our tools that we developed. We can add the same thing to both sides, subtract the same thing, divide the same thing, multiply the same thing. Right? And then if your equation you're trying to solve contains any fractions, then we can do multiply both sides by common denominator, eliminate fractions. Okay? So let's work some things through. Here, this is what they would say. 4x minus 12 is equal to 10 plus x. I would want to, subtract x from both sides. So that would be the 3x. Add 3 to both sides. That would be 3x is equal to 13. And then I would divide both sides by the 3. So the x is equal to 13 over 3. So I hope that helps. We'll work some of it in our lab, and see you next time.